Hello students, good morning to all of you. Welcome back to the online classes by Konnur institution. Last class we were discussing about the S block element. Among that we were discussing about the definition of the S block element and group 1 elements and group 2 elements. And group 1 elements are called as alkali metals and group 2 elements collectively called as alkaline earth metals. And also we are discussing trends in the atomic radii and ionic radii among in the period and down the group also. In the period horizontal rows, the size of atom is decreases because of the nuclear charge is increases. Because of this reason atomic radii is also decreases. Down the group from lithium to cesium, the size will be increases. Size is increases means atomic radius is also increases. And also we are discussing about the ionization enthalpy. Ionization enthalpy, as we move from top to bottom in a periodic table, the size will be increases. Size is increases means attraction will be less between the nucleus and the outermost shell electron. Hence it is decreases from top to bottom. In period, that is horizontal rows, size is decreases, so attraction between the nucleus and the electron is increases, hence the ionization enthalpy will be increases. And in today's class we will discuss about some physical properties like melting point and boiling point and color, etc. So let us start with today's chapter, that is the physical properties of the S block element. So that is, first one is a melting point and boiling point. All alkali metals are silvery white color, so these are the soft metals and having a silver white color, and light metals with the low melting point and boiling point. These S block element, that is the first group elements having a low melting point and boiling point. Because of this reason, all the alkali metals, as we already discussed that in yesterday electronic configuration of the first group element, all alkali metal atoms have a single electron in their valency shell. Because of that reason, we are writing the general electronic configuration of that S block will be noble gas in NS1. So as a consequence of this, weaker metallic bond is formed between the atoms. These metals are exist in a crystal form. Those are having a weaker metallic bond. Because of this reason, those alkali metals having a low melting point and boiling point. And second physical property is the density. So that is alkali metal density is quite low as compared to other elements. It means other metals like D block and F block metals, compared to those metals, these S block element having that is a low density as compared to the other elements. Density increases on moving down the group. Density as it is moving from lithium to cesium. It means so lithium having a lesser dense than sodium, sodium having a lesser dense than potassium, potassium having a lesser dense than rubidium, rubidium lesser dense than cesium. It means cesium is more denser than among the first group element. It is increases from top to bottom in a periodic table. So reason is that, so as alkali metals have a weaker metallic bond between them, as we already discussed this, these are exist in a crystal form, metals are exist in a crystal form, those are having a weaker metallic bond between the atoms. They are less closely packed in their crystals. Crystal 3D structure will be there, among that they have a less closely packed in their crystals. On moving down the group, as we already know that atomic mass of the element is increases, hence the density is also increases. Top to bottom, as we already know that lithium to cesium, if you are moving means atomic number is increases. Atomic number is increases means obviously the atomic mass is also increases. Along with that, so value of the atom at lithium to cesium is also increases. Among these two reasons, one is the atomic mass, another one is the volume. Among these two reasons, the atomic mass will be predominates, hence the density will be increases from lithium to cesium. So we are writing the first group element, that is the first one, lithium, sodium, potassium, rubidium and cesium. So as we move from lithium to cesium, atomic mass is also increases and also volume is also increases. So because of the atomic mass is increases means obviously the density will be increases. Hence we are telling that top to bottom density will be increases. Among this one, lithium is the least denser and cesium is the most denser in the first group element. So exception will be there here. So sodium should have less denser than potassium. But the thing is that potassium is less denser than sodium. Reason is that if we write the electronic configuration of the potassium, the D subshell will be D subshell will be there in a potassium, but in case of a sodium, the D subshell is not there. If the D subshell is there in the potassium means volume is increases obviously. Among the two reasons, one is the mass and the volume. Volume will be predominate over the mass, hence the potassium having a lesser than the sodium. This is the one exception you have to remember about this one. And on moving down the group, atomic mass of the element increases, hence the density is also increases. Density of the alkali metal is lower than the water. Obviously the water is more denser than the alkali metals like lithium to cesium we are calling. And now third physical property is metallic nature or electropositive in nature. As we already know that these S block elements are the soft metals. So all the alkali metals are strongly electropositive in nature or they are typical metals. So these are strongly electropositive in nature. It means it will loses the electron easily. All the metals will easily loses the electron. So hence those are called as a electropositive nature. If it loses the electron, so cation will be formed. That is a electropositive nature we are calling. Reason behind this one electropositive nature is that as alkali metals having a lower ionization enthalpy, they readily lose an electron. Therefore, these are said to be electropositive in nature or typical metallic character it's having. So yesterday we were discussing about the ionization enthalpy. These alkali metals, that is the first group element having a low ionization enthalpy. Because of this low ionization enthalpy, it is a tendency to lose the electron easily compared to the other elements in the periodic table. If it loses the electron easily means those will form the electropositive nature will be there for the metals like lithium to cesium. For example, metal M we had taken, M in the sense metal here. So metal will loses the electron. First group element will loses the one electron to get the octet rule and duplet rule. So if it loses the electron, one cation will be formed. This is the electropositive in nature. For example, you can take any metal like lithium. You can take after lithium, if it loses the one electron, lithium plus, that is a cation will be formed, electropositive nature after losing the one electron. So similarly you can write the sodium, potassium, rubidium, cesium, etc. And alkali metals act as a strong reducing agents as they can readily donate the electron. These are act as a reducing agent. Hope you know the meaning of reducing agent. Reducing agent in the sense itself undergoes oxidation, other substance will be reduction. Andra easy agi oxidation agbeku. Oxidation andra in terms of electron, loss of electron anta artha. Metals irudrinda easy agi electron anna loss madkontavu because of the low ionization enthalpy. Ionization enthalpy ಕಡಿಮೆ ಇರೋ ಸಂಬಂಧ ಈ ಮೆಟಲ್ ಏನಾಗ್ತಾವು ಈಸಿಯಾಗಿ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಲಾಸ್ ಮಾಡಿಕೊಂಡು ಕ್ಯಾಟಯಾನ್ಸ್ ಅನ್ನ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತಾವು. ಅದಕ್ಕೆ ಅವು ಎಲೆಕ್ಟ್ರೋಪಾಸಿಟಿವ್ ನೇಚರ್ ಇರ್ತಾವ ಅಂತ ಹೇಳ್ತೀವಿ. ಈಸಿಯಾಗಿ ಆಕ್ಸಿಡೇಷನ್ ಆಗ್ತಾವೆ. ಎಲೆಕ್ಟ್ರಾನ್ ಲಾಸ್ ಆಗಕತ್ತಂದ್ರ ಆಕ್ಸಿಡೇಷನ್ ಆಗಕತ್ತಂತ ಅರ್ಥ. ಈಸಿಯಾಗಿ ಆಕ್ಸಿಡೇಷನ್ ಆಗಕತ್ತಂದ್ರ ಅದಕ್ಕೆ ಏನಂತ ಕರಿಬಹುದು ಅಂದ್ರೆ ಸ್ಟ್ರಾಂಗ್ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ಸ್ ಅಂತ ಈ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ ನಾವು ಕರಿಬಹುದು. This is the one more third property, that is the metallic nature or electropositive nature. And the fourth one is oxidation state, very important. That is all the alkali metals shows a +1 oxidation state and form a monovalent compound. Monovalent in single. So this is a monovalent cation, lithium. You can take the sodium also. Sodium will loses the one electron. So loss of electron can be denoted by the plus sign. This will loses the one electron. Hence we have to write the Na plus by the loss of one electron. So it will form the monovalent cation. All the alkali metals show +1 oxidation state. Why? Because in the outermost shell, lithium to cesium, it is having a 1 electron. After losing a 1 electron, it will stable nature will come, or the stable electronic configuration it will get. Hence the oxidation state of the first group element will be +1. Reason behind that is as alkali metals have only 1 electron in the valency shell, as we already discussed this one. Valency shell daga ಅಥವಾ outermost shell daga ಒಂದೇ electron ಇರೋದ್ರಿಂದ, and also it is having a less ionization, they easily give electron, hence they show +1 oxidation state and form a monovalent compound. So ನಾವು already discussed ಮಾಡಿವಿ, ಅಯನೈಸೇಷನ್ ಎಂಥಾಲ್ಪಿ ಕಡಿಮೆ ಇರೋ ಸಂಬಂಧ ಇವು ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಲಾಸ್ ಮಾಡ್ಕೊಂತಾವು. ಎಷ್ಟು ಲಾಸ್ ಮಾಡ್ಕೊಂತಾವು ಅಂದ್ರೆ 1 ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಲಾಸ್ ಮಾಡ್ಕೊಂಡು ಸ್ಟೇಬಲ್ ಎಲೆಕ್ಟ್ರಾನಿಕ್ ಕಾನ್ಫಿಗರೇಷನ್ ಅನ್ನ ಫಾರ್ಮೇಷನ್ ಆಗುವುದರಿಂದ ಅಲ್ಲಿ ಮೋನೋವೆಲೆಂಟ್ ಕಾಂಪೌಂಡ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತಾವು. ಅದರಿಂದ ಫಸ್ಟ್ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ ಹ್ಯಾವಿಂಗ್ +1 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಅಂತ ಹೇಳ್ತೀವಿ. And fifth physical properties, that is the color. Characteristics, flame coloration. So it will all the alkali metals will form the particular color when we heat that one. ಯಾವಾಗ ಒಂದು ಹೀಟ್ ಮಾಡ್ತೀವೋ ಪರ್ಟಿಕ್ಯುಲರ್ ಕಲರ್ ಅನ್ನ ಎಕ್ಸಿಬಿಟ್ ಮಾಡ್ತಾವು. ಯಾಕೆ ಮಾಡ್ತೀವಿ ಅನ್ನೋದು ನಾವು ಈಗ ಕಲಿತೀವಿ. ಸೊ ಫಸ್ಟ್ ಪಾಯಿಂಟ್ ಇಸ್ ದಟ್ alkali metals and their salts on burning give a specific color to the flame. alkali metals ಮತ್ತು ಅದರದ್ದು ಸಾಲ್ಟ್ಸ್ ಏನ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತಾವಲ್ಲ ಅವನ್ನ ನಾವು ಹೀಟ್ ಮಾಡಿದಾಗ ಅವು ಪರ್ಟಿಕ್ಯುಲರ್ ಕಲರ್ ಅನ್ನ ಕೊಡ್ತಾವು. ಫ್ಲೇಮ್ ಇನ್ ದ ಸೆನ್ಸ್ if you heat that one, so that will give the particular color. So reason behind this one is as alkali metals have a low ionization, valency electron of atom or ion absorb heat energy from flame and easily get excited to higher energy levels. Being unstable in higher energy levels, the electron returns to its ground state. The electron returns to its ground state, emitting absorbed energy in the form of radiation, which falls in the visible region and thus appears colored. What it means? ಇದರ ಅರ್ಥ ಏನಂತಂದ್ರೆ, so alkali metals low ionization enthalpy-ಯನ್ನು ಹೊಂದ್ಯಾವು. ಅದು ಎಟಮ್ ಆಗಿರ್ಬೋದು, ಅಯಾನ್ ಆಗಿರ್ಬೋದು. ಯಾವಾಗ ಎನರ್ಜಿಯನ್ನ ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಂತತಿ, ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ದಾಗ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಿರ್ತಾವಲ್ಲ ಅವು ಎನರ್ಜಿಯನ್ನ ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಂಡು ಹೈಯರ್ ಸ್ಟೇಟಿಗೆ ಹೋಗ್ತಾವು, ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟಿಗೆ ಹೋಗ್ತಾವು. ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟ್ ಏನಲ್ಲ, ಸ್ಟೇಬಲ್ ಅಲ್ಲ. ವೈಲ್ ಕಮಿಂಗ್ ಬ್ಯಾಕ್ ದಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ಟು ದ ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್, ದಟ್ ವಿಲ್ ಎಮಿಟ್ ದ ಎನರ್ಜಿ ಇನ್ ದ ಫಾರ್ಮ್ ಆಫ್ radiation that will be present in a visible region, that is a 400 nanometer to 700 nanometer. ಅಂದೇನರ್ಥ, ಗ್ರೌಂಡ್ ಸ್ಟೇಟ್ ದಾಗ ಇರತಕ್ಕಂತ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಿರ್ತಾವಲ್ಲ ಯಾವಾಗ ಹೀಟ್ ಮಾಡ್ತೀವಿ ಎನರ್ಜಿ ಕೊಟ್ಟಂಗ ಅವಕ್ಕ. ಸೊ ಎನರ್ಜಿ ತಗೊಂಡು ಏನ್ ಮಾಡ್ತಾವ, ಎನರ್ಜಿಯನ್ನ ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಂತಾವ ಎಲೆಕ್ಟ್ರಾನ್. ಅವು ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಟಿಗೆ ಹೋಗ್ತಾವು. ಎಕ್ಸೈಟೆಡ್ ಸ್ಟೇಬಲ್ ಅಲ್ಲ, ವಾಪಸ್ ಆ ಎಲೆಕ್ಟ್ರಾನ್ ಗ್ರೌಂಡ್ ಸ್ಟೇಟಿಗೆ ಬರೋ ಮುಂದಾಗ ಅಬ್ಸಾರ್ಬ್ ಮಾಡಿರ್ತಕ್ಕಂತ ಎನರ್ಜಿಯನ್ನ ಏನ್ ಮಾಡ್ತಾವು, ಎಮಿಟ್ ಮಾಡ್ತಾವು ರೇಡಿಯೇಷನ್ ಫಾರ್ಮ್ ದಾಗ. ಆ ರೇಡಿಯೇಷನ್ ಏನಿರ್ತೈತಿ ವಿಸಿಬಲ್ ರೀಸನ್ ದಾಗ ಇರ್ತೈತಿ, ಅಂದ್ರೆ 400 ನ್ಯಾನೋಮೀಟರ್ ಟು 700 ನ್ಯಾನೋಮೀಟರ್ ರೀಸನ್ ದಾಗ ಇರ್ತೈತಿ. ನಮಗ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಕಲರ್ ಕಾಣ್ತಿರ್ತೈತಿ. ಸೊ ದಟ್ ಇಸ್ ದ ರೀಸನ್ ಬಿಹೈಂಡ್ ವೈ ದ alkali metals having a particular color when we heat that one. This is the reason. And so we have a particular color in the case of lithium, sodium, potassium, rubidium, cesium. So francium, as we already know that there is a radioactive element. If we are discussing about the property, we have to discuss about up to the cesium. We have to remember that point also. And here characteristic property of the S block element, when we heat that one, what type of a color will be exhibited, that we are writing here. So these are the group 1 element, lithium, sodium, potassium, rubidium, cesium. Flame of the color, it will be give the deep red color, and sodium will give the golden yellow color, and the potassium will give the lilac color, and rubidium will give the bluish red color, and cesium will give the blue color when we heat that one. And also later we will discuss about the group 2 elements as we written in the slide. I will tell the one more time. Group 2 elements like calcium, strontium, barium will give the brick red, blood red color or green color respectively. Later again we will discuss about that. These are the some particular color when we heat through the flame will give the particular color because of the excitation of electron from the ground state to the excited state. While coming back that electron to the ground state, that will exhibit the radiation or absorbed energy in the visible region. And one more physical property, that is one more property, that is a photoelectrical effect. alkali metals emit the electrons when the radiation strikes their surface. ಯಾವಾಗ ಈ ಮೆಟಲ್ಸ್ ಮೇಲೆ ಸೊ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ರೇಡಿಯೇಷನ್ ಬೀಳ್ತೈತಿ ಅವಾಗ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಎಮಿಟ್ ಮಾಡ್ತಾವು, ಲಾಸ್ ಮಾಡ್ಕೊಂತಾವು. ಅದಕ್ಕೆ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಇಫೆಕ್ಟ್ ಅಂತ ಕರಿತೀವಿ. ರೀಸನ್ ಬಿಹೈಂಡ್ ದಿಸ್ ಫಾರ್ ದ ಎಮಿಷನ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ when the radiation strikes on the metal surface is that as alkali metals having a lower ionization enthalpy and therefore the electrons are easily eject when exposed to radiation of proper energy. ಅಂದ್ರೆ ನಾವು alkali metals lower ionization enthalpy ಹೊಂದಿರೋದ್ರಿಂದ ಯಾವಾಗ ಮೆಟಲ್ಸ್ ಮೇಲೆ ರೇಡಿಯೇಷನ್ ಬೀಳ್ತೈತಿ ಅವಾಗ ಈಸಿಯಾಗಿ ಅಯನೈಸೇಷನ್ ಎನರ್ಜಿ ಕಡಿಮೆ ಇರೋದ್ರಿಂದ ಈಸಿಯಾಗಿ ಎಲೆಕ್ಟ್ರಾನ್ ಏನಾಗ್ತಾವು ಇಜೆಕ್ಟ್ ಆಗ್ತಾವು. ಇಂಥ ಪ್ರಾಪರ್ಟಿಯನ್ನ ಫೋಟೋ ಎಲೆಕ್ಟ್ರಿಕಲ್ ಇಫೆಕ್ಟ್ ಅಂತ ಕರಿತೀವಿ. These the first group elements having a low ionization enthalpy, it will eject the more electrons when the radiation will strike on the surface of the metal. And one more note you have to remember here, cesium and potassium are used in the electrodes and the photoelectrical cells. ಇವನ್ನ photoelectrical cells ದಾಗ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಥವಾ ಎಲೆಕ್ಟ್ರೋಡ್ ಆಗಿ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಯಾಕಂತಂದ್ರೆ ಸೊ ಅವು ರೇಡಿಯೇಷನ್ ಅದ್ರ ಮೇಲೆ ಬಿತ್ತಂದ್ರೆ ಈಸಿಯಾಗಿ ಏನಾಗ್ತೈತಿ ಎಲೆಕ್ಟ್ರಾನ್ ಇಜೆಕ್ಟ್ ಆಗ್ತಾವ. ಯಾಕೆ ಇವನ್ನ ಯೂಸ್ ಮಾಡ್ತೀವಿ ಅಂದ್ರೆ as we already know that from the lithium to cesium size will be increases. Size is increases means less attraction will be there and having a low ionization energy. Because of that reason it will easily emit the electrons when radiation strikes on this surface. Hence these are used in the particular like in photoelectrical cells and also used as a electrodes in a particular reactions. Yes sir, still now we discussed about the physical properties like melting point and boiling point and also color, and also we were discussing about the some more physical properties. Now we will discuss about the chemical properties of first group element. So that is alkali metals are highly reactive in nature and due to the following reasons. These are highly reactive in nature as we already discussed in the earlier classes also in the periodic properties. Because of the reason is that low ionization enthalpy, ಇವು ಕಡಿಮೆ ionization enthalpy ಹೊಂದಿರೋದ್ರಿಂದ ಈಸಿಯಾಗಿ ಬೇರೆದರ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗ್ತಾವು, ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಲಾಸ್ ಮಾಡಿಕೊಂಡು. ಅಂಡ್ ಲೋ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಅಟಮೈಸೇಷನ್ ಮೀನ್ಸ್ ಅಟಮ್ಸ್ ಫಾರ್ಮೇಷನ್ ಆಗೋದು. ಸೊ ಲೋ ಎಂಥಾಲ್ಪಿ ಆಫ್ ಅಟಮೈಸೇಷನ್ ಹೊಂದಿರೋದ್ರಿಂದ ಇವು ಹೈಲಿ ರಿಯಾಕ್ಟಿವ್ ನೇಚರ್ ಅನ್ನ ಹೊಂದಿರ್ತಾವ ಅಂತ ಹೇಳ್ತೀವಿ. Down the group ionization enthalpy is decreases. Yesterday class we were discussing about the ionization enthalpy. It's very important. Down the group ionization enthalpy is decreases because size is increases. Size is increases means attraction will be decreases. If the attraction is less, in the sense it can easily lose the electron. We can pick out the one electron from the particular atom with the lowest ionization enthalpy. Hence the reactive nature increases from lithium to cesium. Andra reactive nature lithium to cesium ಹೆಚ್ಚಾಕೊಂತ ಹೋಗ್ತದೆ. ಅಂದ್ರೆ cesium is more reactive than rubidium. Rubidium is more reactive than potassium. Potassium is more reactive than sodium and lithium respectively. So that is we are writing here reactive nature increases from lithium to cesium ಅಂತ ಹೇಳ್ತೀವಿ. And first chemical property of the first group element, that is a reactivity towards the air. So it means what? Air ಜೊತೆ ಫಸ್ಟ್ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ ಲಿಥಿಯಂ, ಸೋಡಿಯಂ, ಪೊಟ್ಯಾಸಿಯಂ, ರುಬಿಡಿಯಂ, ಸೀಸಿಯಂ ಆಗಿರ್ಬೋದು, ಇವೆಲ್ಲ ಏರ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆದಾಗ ಏನ್ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತಾವ ಅನ್ನೋದನ್ನ ನಾವು ಈಗ ಡಿಸ್ಕಷನ್ ಮಾಡ್ತೀವಿ. When the alkali metals are exposed to air, their surface gets tarnished, in the sense it is blackened. So due to the formation of oxides, ಅಂದ್ರೆ ಯಾವಾಗ ಇವು ಏರ್ ಜೊತೆ ಎಕ್ಸ್ಪೋಸ್ ಆಗ್ತಾವು, ಏರ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗ್ತಾವು ಯಾವ ಅಂತಂದ್ರ ಫಸ್ಟ್ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ ಅವೇನಾಗ್ತತಿ, ಸೊ ಇಟ್ ಗೆಟ್ ಟರ್ನಿಶ್ಡ್ ಆರ್ ಬ್ಲ್ಯಾಕೆಂಡ್, ಬ್ಲ್ಯಾಕ್ ಕಲರ್ ಫಾರ್ಮೇಷನ್ ಆಗುತ್ತೆ. ಅದಕ್ಕಂದ್ರ ಆಕ್ಸೈಡ್ ಲೇಯರ್ ಫಾರ್ಮೇಷನ್ ಆಗಿರ್ತತಿ. ಏರ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆದಾಗ ಆಕ್ಸೈಡ್ ಲೇಯರ್ ಫಾರ್ಮೇಷನ್ ಆಗಿರೋದ್ರಿಂದ ಸೊ ದೇ ಗೆಟ್ ಟರ್ನಿಶ್ಡ್ ಅಂತ ಹೇಳ್ತೀವಿ. ಅಂಡ್ ದಿಸ್ ಆಕ್ಸೈಡ್ಸ್ ಫರ್ದರ್ ರಿಯಾಕ್ಟ್ಸ್ ವಿತ್ ವಾಟರ್. ಆ ಫಾರ್ಮೇಷನ್ ಆಗಿರ್ತಕ್ಕಂಥ ಆಕ್ಸೈಡ್ಸ್ ಮತ್ತು ವಾಟರ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗಿ ದಟ್ ವಿಲ್ ಬಿ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು ಹೈಡ್ರಾಕ್ಸೈಡ್ಸ್. ಫಸ್ಟ್ ಏನಾಗುತ್ತಾ, ಏರ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗಿ ಆಕ್ಸೈಡ್ಸ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತಾವ, ಮೆಟಲ್ ಆಕ್ಸೈಡ್ಸ್ ಅಂತ ಹೇಳ್ತೀವಿ. ವೆನ್ ದ ಮೆಟಲ್ ರಿಯಾಕ್ಟ್ಸ್ ವಿತ್ air are exposed to the air, that will form the particular oxides. Those oxides further reacts with the water, it will form the corresponding hydroxides or the metal hydroxides anta ಹೇಳ್ತೀವಿ. Now we written the some examples regarding this one. M in the sense here metal. So metal reacts with the oxygen. So oxygen, air containing oxygen. So that will be form the metal oxides. Metal oxides will be formed. Here first group element having a oxidation state +1 will be there. So that is a metal, +1 will be there. Oxygen O2. This is a 0 oxidation states. When it reacts with this one, so this MO, this is having a -2 charge. Metal first group element having a +1 charge. So charge should be balanced here. Hence we have to take the M2O. This is the M2O is the metal oxides, corresponding metal oxides. For example, so if you balance this one, here 2 metal will be there and 1 oxygen will be there. At the left side 1 metal will be there and 2 oxygen will be there. Hence we have to multiply here 2. Here multiplication ಮಾಡಬೇಕು, 2 oxygen ಅದು 2 2s are 4. So 4 metals will be there. Hence we have to multiply by the 4. So instead of metal you can take the any example like lithium reacts with the oxygen. That is a lithium oxide will be formed. So we can multiply by 2. Here it is 4. And other metals like sodium reacts with the oxygen or air. It will form the sodium oxide, Na2O. Why we are writing Na2O? As we already discussed here, charge should be balanced in the molecule. So that is 2 2s are 4. Here it is 4 sodium, 2 oxygen will be there, and corresponding metal oxides will be formed. That we are writing here. Metal reacts with the oxygen, metal oxides are formed. These formed metal oxides are reacts with the water to form a corresponding hydroxides. Andra ee formation ಆಗಿರತಕ್ಕಂತ metal oxides ಏನದಾವಲ್ಲ ಅವು ಏನು ವಾಟರ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗಿ metal hydroxides ಅನ್ನು ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತಾವೆ. Metal oxides ಅಂದ್ರೆ we written as M2O. Metal may be water, lithium to cesium you can write. That is reacts with the H2O and will form the metal hydroxides. This is OH minus 1 charge, M, that is a metal having a +1 charge. So to multiply 2 in the balance the metal and oxygens. So M2O plus H2O will give the 2 MOH, that is a metal hydroxides. And also these metal hydroxides will be reacts with the carbon dioxide present in the what it is air. Air dagiರ್ತಕ್ಕಂತ ಕಾರ್ಬನ್ ಡೈಆಕ್ಸೈಡ್ ಜೊತೆ ಈ ಮೆಟಲ್ ಹೈಡ್ರಾಕ್ಸೈಡ್ಸ್ ರಿಯಾಕ್ಟ್ ಆಗಿ ಮೆಟಲ್ ಕಾರ್ಬೋನೇಟ್ಸ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತಾವೆ. ದಟ್ ಇಸ್ ವಿ ಆರ್ ಕಾಲಿಂಗ್ ಆಸ್ ದ M2CO3. This CO3 having a -2 charge. So this is metal having a +1 charge. This is first group element having a +1 charge, and this is CO3 -2 charge. To balance the charge we have to take the 2 metal, hence M2CO3 is a metal carbonates will be formed. Along with that H2O will be liberated. So this is a one more reactive nature of the chemical property of the first group element. The point is that here when the metal reacts with the air it will form the metal oxides. Those metal oxides reacts with the water to form a metal hydroxides. So again metal hydroxides, if it reacts with the carbon dioxide, metal carbonates will be formed. And second one is when the heated vigorously with the air or oxygen, they form a different types of oxides. Andra air athwa heat ಮಾಡಿದಾಗ ಅಥವಾ ಏರ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆದಾಗ ಆಕ್ಸಿಜನ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆದಾಗ ಬೇರೆ ಬೇರೆ ಟೈಪ್ ಆಕ್ಸೈಡ್ಸ್ ಅನ್ನ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತಾವೆ ಫಸ್ಟ್ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್. ಅವು ಯಾವ ಅಂತ ನೋಡ್ತೀವಿ. ಲಿಥಿಯಂ ಫಾರ್ಮ್ಸ್ ದ ಮೋನೋ ಆಕ್ಸೈಡ್. ಲಿಥಿಯಂ ಒಂದೇ ಏನ್ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತದೆ ಅಂದ್ರೆ ಮೋನೋ ಆಕ್ಸೈಡ್ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತದೆ. ಅದರ್ ದ್ಯಾನ್ ದ ಲಿಥಿಯಂ ದೋಸ್ ವಿಲ್ ನಾಟ್ ಫಾರ್ಮ್ ದ ಮೋನೋ ಆಕ್ಸೈಡ್ಸ್. Instead of that they will form the super oxides and peroxides will be formed. That is the sodium will form the peroxides. So here we can sodium reacts with the oxygen Na2O2. That is the charge of the oxygen will be -2 here. So this is -2 and here it is +1 will be there. 1 sodium +1 and the 2 sodium, that is a +2. Charge will be balanced. This is a superoxide here. Here lithium reacts with the oxygen, so lithium monoxide will be formed. What about the charge here? So -2, it is a +2. So lithium will form the monoxide and the sodium will form the peroxide. Other than the sodium, like potassium, rubidium, cesium. So here superoxides will be formed, which are those potassium, rubidium and cesium. These metals will form when it reacts with the oxygen, that will form the superoxides. That is the charge of that superoxide will be O2 -1. O2 -1. That is a M in the sense here potassium, rubidium, cesium. So those will react with the oxygen to form the superoxides. The charge of the superoxide will be here, -1 will be there. Metal, these are first group element, that is the +1 will be there. So here O-2 is called as a normal oxide, and that is a monoxide will be formed, and per oxide O2-2, that is the point is that here only one oxygen will be there, monoxide, O2-2 per oxide, and here one more O2-1, that is a superoxide. Point to be noted, lithium only the metal which will form the monoxide in the first group element. Sodium will form the peroxide other than the sodium in the first group, like potassium, rubidium and cesium will form the superoxides. In all the oxides, the oxidation state of the metal is +1. ಎಲ್ಲ ಆಕ್ಸೈಡ್ಸ್ ಆಗಿ whether it may be monoxide ಇರಬಹುದು ಅಥವಾ peroxide ಇರಬಹುದು ಅಥವಾ ಸೂಪರ್ ಆಕ್ಸೈಡ್ ಇರಬಹುದು, ಎಲ್ಲಾದ್ರಾಗ ಆಕ್ಸೈಡ್ಸ್ ದಾಗು ಮೆಟಲ್ ದ ಚಾರ್ಜ್ ಏನಿತ್ತಂದ್ರ +1 ಆಕ್ಸಿಡೇಷನ್ ಸ್ಟೇಟ್ ಆಗಿತ್ತು. ಬಟ್ ಆಕ್ಸಿಜನ್ ದ ಚಾರ್ಜ್ ಏನಾಕಿತ್ತು, ಬೇರೆ ಬೇರೆ ಆಗಿತ್ತು. ಬರೇ O-2 ಇತ್ತಂದ್ರ ನಾರ್ಮಲ್ ಆಕ್ಸೈಡ್ ಅಂತ ಹೇಳ್ತೀವಿ, -2 O2-2 ಇದ್ರ ಪರ್ ಆಕ್ಸೈಡ್ ಅಂತ ಹೇಳ್ತೀವಿ, O2-1 ಇತ್ತಂದ್ರ ಸೂಪರ್ ಆಕ್ಸೈಡ್ ಅಂತ ಹೇಳ್ತೀವಿ. Due to the high reactivity of alkali metals, they are usually kept in a kerosene oil. So ಇವು ಹೈಲಿ ರಿಯಾಕ್ಟಿವ್ ನೇಚರ್ ಹೊಂದೇ ಅಂತ ಆಲ್ರೆಡಿ ಡಿಸ್ಕಷನ್ ಮಾಡಿವಿ. ರಿಯಾಕ್ಟಿವ್ ನೇಚರ್ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ ವೆನ್ ಇಸ್ ಎಕ್ಸ್ಪೋಸ್ ಟು ಏರ್ ಆರ್ ಆಕ್ಸಿಜನ್ ದಟ್ ವಿಲ್ ಈಸಿಲಿ ರಿಯಾಕ್ಟ್ಸ್ ವಿತ್ ದ್ಯಾಟ್. Hence, because of that reason, that will be kept in a kerosene oil or like a benzene, or you can take the ether also. ಸೊ ಅದ್ರಾಗ ಅದನ್ನ ಸ್ಟೋರ್ ಮಾಡಿರ್ತೀವಿ, ಯಾಕಂದ್ರೆ ಅದು ಆಕ್ಸಿಜನ್ ಅಥವಾ ಏರ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗಬಾರ್ದಂತ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ lithium and the sodium when it reacts with the water or the oxygen, that will be exposed to, when it exposed to air, that will catches the fire, adu benki hatkontati. ಅದಕ್ಕೆ ಅದನ್ನ ಕೆರೋಸಿನ್ ಆಯಿಲ್ ದಾಗ ನಾವು ಏನೇನ್ ಮಾಡ್ತಾ ಸ್ಟೋರ್ ಮಾಡಿ ಇಟ್ಟಿರ್ತಾರೆ. lithium also having a less denser, so when it kept in a kerosene oil, the part of the lithium metal will be exposed to air. Because of that reason, that will be wrapped with the aluminum foil. ಅಲ್ಯೂಮಿನಿಯಂ ಫಾಯಿಲ್ ಜೊತೆ ರ್ಯಾಪ್ ಮಾಡಿ ಏನ್ ಮಾಡಿರ್ತಾರ, ಅದ್ರಾಗ ಡಿಪ್ ಮಾಡಿಟ್ಟಿರ್ತಾರೆ. ಯಾಕಂದ್ರೆ ಯಾವಾಗ ಅದನ್ನ ತೇಲ್ತಿರ್ತೈತಿ ಕೆರೋಸಿನ್ ಆಯಿಲ್ದಾಗ, ಆ ಲಿಥಿಯಂ ಸ್ವಲ್ಪ ಪಾರ್ಟ್ ಏನಾಗ್ತೈತಿ ಏರ್ ಜೊತೆ ಎಕ್ಸ್ಪೋಸ್ ಆದಾಗ ಅದು ರಿಯಾಕ್ಟ್ ಆಗುವಂತ ಚಾನ್ಸಸ್ ಇರ್ತೈತೆ ಅನ್ನೋ ಸಂಬಂಧ ಅದಕ್ಕೆ ಏನ್ ಮಾಡ್ತಾರ, ಅಲ್ಯೂಮಿನಿಯಂ ಫಾಯಿಲ್ ಅನ್ನ ಸುತ್ತ ಬಿಟ್ಟು ಆ ಕೆರೋಸಿನ್ ಆಯಿಲ್ದಾಗ ಇಟ್ಟಿರ್ತಾರ. ಸೊ ಡ್ಯೂ ಟು ದ ಹೈ ರಿಯಾಕ್ಟಿವಿಟಿ ಆಫ್ alkali metals, these are usually kept in a kerosene oil, or you can take the benzene also or ether also. Lithium shows exceptional behavior by reacting directly with the nitrogen and forms a lithium nitride. ಇದು ಒಂದು ಬೇರೆ ಕ್ಯಾರೆಕ್ಟರ್ ಅನ್ನ ತೋರಿಸುತ್ತದು. ಲಿಥಿಯಂ ಒಂದೇ ನೈಟ್ರೋಜನ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತಾ, ಬೇರೆ ಫಸ್ಟ್ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ ಯಾವ ಏನಾಗುದಿಲ್ಲ ಅಂತಂದ್ರ ನೈಟ್ರೋಜನ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗುದಿಲ್ಲ. ಲಿಥಿಯಂ ಒಂದು ನೈಟ್ರೋಜನ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗಿ ಲಿಥಿಯಂ ನೈಟ್ರೈಡ್ ಅನ್ನ ಫಾರ್ಮೇಶನ್ ಮಾಡ್ತಾವು. ಸೊ ದಿಸ್ ಇಸ್ ಐ ಥಿಂಕ್ ರಾಂಗ್, ಇಟ್ ಈಸ್ ದಿಸ್ ಶುಡ್ ಬಿ Li3n. So now lithium reacts with the nitrogen, it will form the lithium nitride. This is lithium nitride. How many nitrogens are there? At the left side 2 nitrogens will be there, hence we have to multiply with the 2, and 2 3s are 6 lithiums are, hence we have to multiply with the 6. 6 lithium reacts with the nitrogen to form a lithium nitride. This is the one more property of lithium it is. Other than the lithium, that sodium, potassium, rubidium, cesium will not react with the nitrogen. Only the lithium will react and form a lithium nitride. So you have to make it correct. This one Li3, it's not Li3, this is the Li3n. And second chemical property of the first group elements will be reaction with water. When it reacts with the water, what type of products will be formed? Now we will discuss that. All alkali metals reacts with the water and form metal hydroxide with the liberation of hydrogen gas. ಯಾವಾಗ ಇವು ವಾಟರ್ ಜೊತೆ ರಿಯಾಕ್ಷನ್ ಆಗ್ತಾವು, ಸೊ ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಮೆಟಲ್ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಫಾರ್ಮೇಶನ್ ಆಗ್ತಾವು ಅಲಾಂಗ್ ವಿತ್ ದ ಲಿಬರೇಷನ್ ಆಫ್ ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್. ಹೈಡ್ರೋಜನ್ ಗ್ಯಾಸ್ ಲಿಬರೇಷನ್ ಆಗೋದ್ರ ಜೊತೆಗೆ ಮೆಟಲ್ ಹೈಡ್ರಾಕ್ಸೈಡ್ ಫಾರ್ಮೇಶನ್ ಆಗ್ತಾವು. ಮೆಟಲ್ ಇನ್ ದ ಸೆನ್ಸ್ ಹಿಯರ್ ಕ್ಯಾನ್ ಟೇಕ್ ದ ಲಿಥಿಯಂ ಟು ಸೀಸಿಯಂ, ಯಾವ್ದಾದ್ರು ಒಂದು ತಗೋಬಹುದು. ಸೊ ನೀವು ಈಗ ಮೆಟಲ್ ಚಾರ್ಜ್ ಏನೈತಿ, ನಮ್ +1 ಚಾರ್ಜ್ ಐತಿ, metal is the charge +1 other, so metal reacts with the H2O. So this can be dissociated into H plus and OH minus. All the metals are electropositive nature. this metal reacts with the OH minus to form a metal hydroxides, MOH. That's the metal hydroxides will be formed. To balance the oxygen and the hydrogen, you have to multiply here 2 and 2 hydrogens will be there. 2, 2. Total 4 hydrogens are there. Here 2 2s are 4 hydrogens will be there. 2 oxygens are there. Here 2 oxygens are there. And 2 metals will be there. 2 metals will be there. So this point is that here when it reacts with the water, it will form the corresponding metal hydroxides along with the liberation of hydrogen. Here metal you can take any from lithium to cesium. Example, we have taken a sodium reacts with a H2O. Sodium is the metal, it is reacts with water. It can be split up into H plus and OH minus. This sodium, after the loss of electron, it will form the sodium plus ion in the water. That will be reacts with the OH minus. That is a sodium hydroxide will be formed. Sodium hydroxide will be formed along with the liberation of hydrogen gas. That's we are written here. So NaOH plus H2. Here oxygen will be hydrogen you have to balance and oxygen you have to balance with the multiplication of 2, 2. Here also 2 NaOH and H2 gas will be liberated. Same we are written a potassium. Potassium reacts with the H2O, potassium hydroxide along with the liberation of H2O. You can write the rubidium, cesium also, same formula. So H2O reacts with those metals will form the corresponding hydroxides. And alkali metals are normally kept in inert solvents, as we already discussed in the earlier slide only. Alkali metals are normally kept in inert solvents like kerosene, benzene or ether. So ಬೇರೆ ಯಾವುದಾದರೂ ನೀವು ಸಾಲ್ವೆಂಟ್ಸ್ ದಾಗ ಇಡಬಹುದು, ಕೆರೋಸಿನ್ ಆಗಿರಬಹುದು, ಬೆಂಜಿನ್ ಆಗಿರಬಹುದು, ಅದು ಈಥರ್ ಆಗಿರಬಹುದು, ಯಾವ್ದಾದ್ರೂ ಸ್ಟೋರ್ ಮಾಡಿರಬಹುದು. ಯಾಕೆ ಸ್ಟೋರ್ ಮಾಡಿರ್ತಾರೆ ಅಂತ ಹೇಳಿದ್ನೆ, ರಿಯಾಕ್ಟಿವ್ ನೇಚರ್ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ ಅದು ಯಾವಾಗ ಏರ್ ಜೊತೆ ಅಥವಾ ಆಕ್ಸಿಜನ್ ಜೊತೆ ಎಕ್ಸ್ಪೋಸ್ ಆಗ್ತದೆ ಅದ್ರ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗಿ ಬೆಂಕಿ ಹತ್ಕೊಂತೈತಿ. ಅದಕ್ಕೆ ಅವ್ನು ಏನ್ ಮಾಡಿರ್ತಾರ, ಸ್ಟೋರ್ ಮಾಡಿ ಇಟ್ಟಿರ್ತಾರ. ಸೊ to prevent them from coming in contact with the air or moisture ಜೊತೆ ಏರ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗಬಾರ್ದು ಅನ್ನೋ ಉದ್ದೇಶಕ್ಕೆ ಅವ್ನು ಏನ್ ಮಾಡಿರ್ತಾರ, ಸ್ಟೋರ್ ಮಾಡಿ ಇಟ್ಟಿರ್ತಾರ. This is one more chemical property of that first group element, that is alkali metals. And third chemical property is reactivity with hydrogen. What happens if it reacts with the hydrogen? Very simple. All the alkali metals reacts with the hydrogen at 673 Kelvin except the lithium, which reacts with 1073 Kelvin to form a metal hydrides. ಯಾವಾಗ ಈ ಮೆಟಲ್ ಹೈಡ್ರೋಜನ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗ್ತಾವು ಏನ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತಾವ ಅಂದ್ರೆ ಮೆಟಲ್ ಹೈಡ್ರೈಡ್ಸ್ ಫಾರ್ಮೇಷನ್ ಆಗ್ತಾವು. ಸೊ ಫಸ್ಟ್ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್ ಹ್ಯಾವಿಂಗ್ a +1 charge and a hydrogen, this hydride having a -1 charge here. So that is a H2 will be there. This is a neutral molecule. When it reacts with a hydrogen, metal hydrides will be formed. So here it is hydride -1, here it is +1. Charge should be balanced. Metal hydrides will be there. 2 hydrogens are there here. Here 1 hydrogen is there. Hence we have to multiply with the 2. 2 metals will be there. Hence we have to multiply with the 2 corresponding metal hydrides. But all the except the lithium, all the metal will react with the hydrogen at 673 Kelvin. Only the lithium will react with at 1073 Kelvin. That will also form the metal hydrides. Reactivity of those metal hydrides will be lithium hydride is more reactive than sodium, sodium is more reactive than potassium, potassium is more reactive than rubidium, rubidium is more reactive than cesium ಅಂತ ಹೇಳ್ತೀವಿ. Stability of the metal hydrides. Metal hydride stability ಯಾವ್ದು ಇರ್ತದೆ ಅಂದ್ರೆ, so as we move from lithium hydride to the cesium hydride, it will be decreases. Lithium hydride will be more stable than the sodium hydride. Stability of the any molecule, you can take that if the size will be almost similar, this is the more stable in nature. Size ಎರಡರದು almost similar ಇತ್ತಂದ್ರೆ ಸ್ಟೆಬಿಲಿಟಿ ಜಾಸ್ತಿ ಇರ್ತದ. ಇಲ್ಲಿ lithium, sodium, potassium, rubidium, cesium, hydrogen same ಐತಿ, ಮೆಟಲ್ ಅಷ್ಟ ಚೇಂಜ್ ಆಕೊಂತ ಹೋಗುತ್ತಾ. As we move from top to bottom in a periodic table, size will be increases. The hydride size will, hydrogen size will be same here, and here metal size will be increases. If the size variation will be more, means this will be unstable nature. Size almost similar ಇದ್ದು ಅಂದ್ರೆ ಸ್ಟೆಬಿಲಿಟಿ ಜಾಸ್ತಿ ಇರ್ತೈತಿ. size variation ಜಾಸ್ತಿ ಇತ್ತಂದ್ರೆ it may be this is the cation, this is the anion here, so it may be anion will be larger, cation will be smaller. This is also unstable nature. ಇದು ಜಾಸ್ತಿ ಕಡಿಮೆ ಸ್ಟೆಬಿಲಿಟಿ ಅನ್ನು ಹೊಂದಿರ್ತದೆ ಅಂತ ಹೇಳ್ತೀವಿ. Here lithium hydride size almost similar ಅದಾವ. ಇಲ್ಲಿ ಮೆಟಲ್ ದ ಸೈಜ್ ಏನಕ್ಕೊಂತ ಹೋಗುತ್ತಾ ದೊಡ್ಡದಕ್ಕೊಂತ ಮೆಟಲ್ ದ ಸೈಜ್ ದೊಡ್ಡದಕ್ಕೊಂತ ಹೋಗುತ್ತೆ. If the metal size is increases means stability of the hydride will be decreases. These are strong reducing agents and reducing nature increases down the group. Reducing agent ಅಂದ್ರೆ ಯಾಕಂತ ಹೇಳಿದ್ದೆ ನಾನು, ಸೊ ಈಸಿಯಾಗಿ ಲಾಸ್ ಮಾಡ್ಕೊಂತೈತಿ, ಸೊ ಆಕ್ಸಿಡೇಷನ್ ಆಗ್ತಾವು. These are strong reducing agent and their reducing nature increases from the group. So that is a reducing nature increase ಆಕೊಂತ ಹೋಗುತ್ತೆ. ಅಲ್ಲಿಂದ ಅಂದ್ರೆ ಲಿಥಿಯಂ ಇಂದ ಹಿಡ್ಕೊಂಡು cesium ತನಕ ಅಂತ ಹೇಳ್ತೀವಿ. This is one more chemical property, that is a reactivity with a hydrogen. And reaction with the halogens. And fourth property or the chemical property of first group element, that is the reaction with halogens. Halogens means that is the 17th group element, the fluorine, chlorine, bromine, iodine, and astatine will be there, that is the radioactive element. All alkali metals reacts with the halogens and form ionic halides. ಎಲ್ಲ ಮೆಟಲ್ಸ್ ಯಾವಂದ್ರ ಫಸ್ಟ್ ಗ್ರೂಪ್ ಮೆಟಲ್ಸ್ ಅವು ಹ್ಯಾಲೋಜನ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗಿ ಏನ್ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತಂದ್ರ ಅಯಾನಿಕ್ ಹಲೈಡ್ಸ್ ಅನ್ನ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತಾವು. ಸೊ ಚಾರ್ಜ್ ವಿಲ್ ಬಿ +1 and halogen will be -1. Here it is +1. Oxidation state of the first group element will be +1, that will react to form a metal halides. ಇವೇನ್ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತಾವು metal halides ಅನ್ನ ಫಾರ್ಮೇಷನ್ ಮಾಡ್ತಾವು. This halogen exists in a X2 form here. This is the charge of the halogen will be 0 here, and here metal halides will be formed. 2 halogens are there, you have to multiply with the 2, hence we have to multiply with the 2 here. That we written here. Metal reacts with the X2, metal halides will be formed. Metal, you can take any example. We have taken a sodium. Sodium reacts with the chlorine, halogen chlorine we have taken, reacts with the chlorine, sodium chloride ionic compound is formed. So that is, this is the ionic compound. In case of metal halides like lithium halide, sodium halide, potassium halide, rubidium halide and cesium halide, only the lithium halides will form the more covalent compound compared to the other halides, sodium to cesium. ಅಂದ್ರ ಲಿಥಿಯಂ ಹ್ಯಾಲೋಜನ್ಸ್ ಏನದಾವಲ್ಲ ಅವು ಜಾಸ್ತಿ ಕೋವಲೆಂಟ್ ಕ್ಯಾರೆಕ್ಟರ್ ಅನ್ನ ಹೊಂದಿರ್ತಾವು. ಸೊ ಉಳಿದಿದ್ದು ಎಲ್ಲವೂ ಅಯಾನಿಕ್ ಕ್ಯಾರೆಕ್ಟರ್ ಅನ್ನ ಜಾಸ್ತಿ ಹೊಂದಿರ್ತಾವೆ. ಯಾಕಂತಂದ್ರ ಲಿಥಿಯಂ ಹ್ಯಾವಿಂಗ್ ಅ ಸ್ಮಾಲೆಸ್ಟ್ ಸೈಜ್ ಇನ್ ದ ಗ್ರೂಪ್, ಆ ಗ್ರೂಪ್ ದಾಗ ಸೋಲಿಸಿದ್ರ ಲಿಥಿಯಂ ದ ಸ್ಮಾಲ್ ಸೈಜ್ ಐತಿ. ಸ್ಮಾಲ್ ಸೈಜ್ ಇರೋದ್ರಿಂದ ಪೊಲರೈಸಿಂಗ್ ಪವರ್ ಜಾಸ್ತಿ ಇರ್ತೈತೆ. ಫಜಾನ್ಸ್ ರೂಲ್ ನಾವು ಡಿಸ್ಕಷನ್ ಮಾಡಿ ಕೆಮಿಕಲ್ ಬಾಂಡಿಂಗ್ ದಾಗ ಆ ಫಜಾನ್ಸ್ ರೂಲ್ ಪ್ರಕಾರ ಏನ್ ಹೇಳ್ತೀವಿ ಅಂತಂದ್ರೆ ನಾವು ಪೊಲರೈಸೇಷನ್ ಬಗ್ಗೆ ಡಿಸ್ಕಷನ್ ಮಾಡ್ತೀವಿ. ಇದು ಸೈಜ್ ಸಣ್ಣದಿರೋದ್ರಿಂದ ಇದ್ರ ಪೊಲರೈಸಿಂಗ್ ಪವರ್ ಜಾಸ್ತಿ ಇತ್ತು. ಅಂದ್ರೆ ಪೊಲರೈಸೇಷನ್ ಅಂತಂದ್ರೆ ಏನು, ವೆನ್ ದ ಕ್ಯಾಟಯಾನ್ ಅಪ್ರೋಚಸ್ ದ ಆನಯಾನ್, so it attracts the anionic cloud towards itself, hence that will be distorted to neutralization taking place. That if the distortion taking place means a neutralization will occur. If the neutralization occur means a covalent character is increases because of the smaller size of the lithium. ಲಿಥಿಯಂ ದ ಸ್ಮಾಲರ್ ಸೈಜ್ ಇರೋದ್ರಿಂದ ಪೊಲರೈಸಿಂಗ್ ಪವರ್ ಜಾಸ್ತಿ ಇತ್ತು. ಅಂದ್ರೆ ಆನಯಾನಿಕ್ ಕ್ಲೌಡ್ ಅನ್ನ ತನ್ನ ಕಡೆ ಎಳ್ಕೊಳ್ಳುವಂತ ಶಕ್ತಿ ಜಾಸ್ತಿ ಇದೆ. ಪೊಲರೈಸಿಂಗ್ ಪವರ್ ಜಾಸ್ತಿ ಇರೋದ್ರಿಂದ ಅದು ಕೋವಲೆಂಟ್ ಕ್ಯಾರೆಕ್ಟರ್ ಜಾಸ್ತಿ ಇರ್ತದೆ. ಇನ್ ದ ಸೆನ್ಸ್ lithium halides are more covalent than the other halides like sodium, potassium, rubidium and cesium. Reactivity of these metals with the halogens will be lithium having a lesser reactive than sodium, sodium having a lesser reactive than potassium and rubidium lesser than the cesium. This is due to the fact that down the group ionization energy decreases or electropositive character is increases. Now down the group ಹೋದಂಗೆ ಸೈಜ್ ದೊಡ್ಡದಕ್ಕಂತ ಹೋಗುತ್ತಾ, ಸೈಜ್ ದೊಡ್ಡದಕ್ಕಂತ ಹೋದ್ರೆ ಅಟ್ರಾಕ್ಷನ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ಅಟ್ರಾಕ್ಷನ್ ಕಡಿಮೆ ಐತೆ ಅಂದ್ರೆ ಈಸಿಯಾಗಿ ಹ್ಯಾಲೋಜನ್ ಜೊತೆ ರಿಯಾಕ್ಟ್ ಆಗುತ್ತೆ. hence cesium is more reactive than among this one with the halogens we are discussing. With the hydrides, with the halogens, with the water, different reactivity will be there. So we are talking about the reaction with the halogens. This is the reactivity of halogens. ಹ್ಯಾಲೋಜನ್ ಜೊತೆ ರಿಯಾಕ್ಟಿವಿಟಿ ಆದಾಗ ಅಷ್ಟೇ ಇದನ್ನ ಡಿಸ್ಕಷನ್ ಮಾಡಿ, ಹೈಡ್ರೈಡ್ಸ್ ಜೊತೆ ಬೇರೆ ಡಿಸ್ಕಷನ್ ಮಾಡಿದ್ವಿ, ಇಲ್ಲಿ ಹ್ಯಾಲೋಜನ್ ಜೊತೆ ಡಿಸ್ಕಷನ್ ಮಾಡಕತ್ತೀವಿ. ದಿಸ್ ಇಸ್ ಅಬೌಟ್ ದ ರಿಯಾಕ್ಷನ್ ವಿತ್ ದ ಹ್ಯಾಲೋಜನ್ಸ್ ವೆನ್ ಇಟ್ ರಿಯಾಕ್ಟ್ಸ್ ವಿತ್ ಅ ಪರ್ಟಿಕ್ಯುಲರ್ ಫಸ್ಟ್ ಗ್ರೂಪ್ ಎಲಿಮೆಂಟ್, ಕರೆಸ್ಪಾಂಡಿಂಗ್ ಅಯಾನಿಕ್ ಕಾಂಪೌಂಡ್ ವಿಲ್ ಬಿ ಫಾರ್ಮ್. That to be in case of lithium only, lithium halides are more covalent than the other halides. And one more chemical property, that is the reducing nature. Reducing nature ಅಂದ್ರೆ ನಮಗೆ ಏನು ಗೊತ್ತಾಯ್ತು? Reducing nature ಅಂದ್ರೆ ಏನು? ತಾ ಆಕ್ಸಿಡೇಷನ್ ಆಗಬೇಕು, ಬೇರೆದರನ್ನ ರೆಡ್ಯೂಸ್ ಮಾಡಬೇಕು. ಹೌದಾ? All alkali metals are strong reducing agent. ಎಲ್ಲ alkali metals ಏನದಾವು strong reducing agent ಹೊಂದ್ಯಾವು, because those will lose the electron easily because of the low ionization energy. This is because of low ionization enthalpy, they can easily lose or donate the electron. ಈಸಿಯಾಗಿ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಲಾಸ್ ಮಾಡ್ಕೊಳ್ಳೋದ್ರಿಂದ ಅವು ಆಕ್ಸಿಡೇಷನ್ ಆಗ್ತಾವು. ಆಕ್ಸಿಡೇಷನ್ ಆಗ್ತಾವ ಅಂತಂದ್ರೆ ಈಸಿಯಾಗಿ ಅವಕ್ಕೆ ಏನ್ ಅನ್ಬೋದು ಅಂದ್ರೆ ಸ್ಟ್ರಾಂಗ್ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ಸ್ ಅಂತ ಅನ್ಬೋದು. Down the group ionization energy decreases, hence the reducing properties also increases. ಅಂದ್ರೆ ಯಾವ್ದು ಈಸಿಯಾಗಿ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಲಾಸ್ ಮಾಡ್ಕೊಂತೈತೆ ಅಂದ್ರೆ ಯಾವ್ದು ಸೈಜ್ ದೊಡ್ಡದೈತೆ ಅದು ಈಸಿಯಾಗಿ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಲಾಸ್ ಮಾಡ್ಕೊಂತೈತಿ, ಯಾಕಂದ್ರೆ ಅಟ್ರಾಕ್ಷನ್ ಕಡಿಮೆ ಇರ್ತೈತಿ. ಅಟ್ರಾಕ್ಷನ್ ಕಡಿಮೆ ಇತ್ತಂದ್ರೆ ಈಸಿಯಾಗಿ ಎಲೆಕ್ಟ್ರಾನ್ ಅನ್ನ ಲಾಸ್ ಮಾಡ್ಕೊಂತೈತಿ. ಅದು ಈಸಿಯಾಗಿ ಎಲೆಕ್ಟ್ರಾನ್ ಲಾಸ್ ಮಾಡ್ಕೊಳಕತ್ತೈತಿ ಅಂದ್ರೆ ಆಕ್ಸಿಡೇಷನ್ ಆದಂಗ ಆತ. ಅದು ಆಕ್ಸಿಡೇಷನ್ ಈಸಿಯಾಗಿ ಆಗತ್ತಂದ್ರೆ ಅದಕ್ಕೆ ಏನಂತ ಅನ್ಬೋದು ಅಂದ್ರೆ ಸ್ಟ್ರಾಂಗ್ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಅಂತ ಕರಿಬಹುದು. So here we are writing the reactivity nature, that is a lithium plus having a lesser than sodium plus than potassium plus than rubidium plus than cesium plus. The point is that here important, in solution lithium is the strongest reducing agent among all the alkali metals. Point is that in solution ದಾಗ lithium strongest reducing agent ಐತಿ, ಬಟ್ ಇಲ್ಲಿ ರೆಡ್ಯೂಸಿಂಗ್ ಪ್ರಾಪರ್ಟಿ ಇನ್ಕ್ರೀಸ್ ಆಗುತ್ತಂದ್ರ ಸೀಸಿಯಂ ರೆಡ್ಯೂಸಿಂಗ್ ಪ್ರಾಪರ್ಟಿ ಜಾಸ್ತಿ ಹೊಂದೈತಿ. ಬಟ್ ಸೊಲ್ಯೂಷನ್ ದಾಗ ಲಿಥಿಯಂ ಇಸ್ ದ ಸ್ಟ್ರಾಂಗೆಸ್ಟ್ ರೆಡ್ಯೂಸಿಂಗ್ ಏಜೆಂಟ್ ಅಮಂಗ್ ಆಲ್ ದ alkali metals. Lithium plus in aqueous, here it is gaseous nature, it is in aqueous more than sodium plus, more than potassium plus, more than rubidium, more than cesium. When it reacts in the solution, that is decided by the, which is the strong reducing agent, that is decided by the potential value, the metal electrode potential value ಆಧಾರದ ಮ್ಯಾಗ ಅದನ್ನ ಡಿಸೈಡ್ ಮಾಡ್ತೀವಿ. The metal which is having a lesser electrode potential is more reducing property. ಅಂದ್ರ ಯಾವುದು electrode potential value ಕಡಿಮೆ ಇರ್ತತಿ ಅದು reducing property ನ ಜಾಸ್ತಿ ಹೊಂದೈತಿ. ಹಂಗಂದ್ರ ಯಾವಾಗ ಸೊಲ್ಯೂಷನ್ ದಾಗ ಲಿಥಿಯಂ ಏನೈತಿ electrode potential value ಕಡಿಮೆ ಇರೋದ್ರಿಂದ ಅದು ಸ್ಟ್ರಾಂಗೆಸ್ಟ್ reducing agent ಅಂತ ಹೇಳ್ತೀವಿ. Point is that here in solution ದ ರಿಯಾಕ್ಟ್ ಆದಾಗ electrode potential value ಕಡಿಮೆ ಇರೋದ್ರಿಂದ ಅದರದ್ದು reducing property ಜಾಸ್ತಿ ಅಂತ ಹೇಳ್ತೀವಿ. Hence we are talking as it is the strongest reducing agent among all the alkali metals ಅಂತ ಹೇಳ್ತೀವಿ. Yes, these are the chemical properties of first group element. In tomorrow class or in next class we will discuss about the anomalous properties of lithium. We'll see you in the next video.